Dear students, welcome to the introduction to your first lab for this semester. I am your teacher Abhishek and I will tell you in this video what exactly you have to do for the first lab. So this is your bright space for this particular module, microcontrollers. And if you go to the My Learning tab here, you will see that I have already created a labs 2019 unit here. Okay, so under your learning materials, you see you have your lecture notes, and then you have this labs unit here. So under the labs unit, you can see there are several subunits. Okay, so the first one is about the Silicon Labs tool stick. So this is the device, the hardware that you will be using for your microcontrollers lab this semester. So you will be given with this hardware in the first lab when you come for the lab. But let me walk you through the different descriptions of the Silicon Lab tool stick. So under this Silicon Labs tool sticks, you will find three PDF documents here. So if you open this one, this is basically a long PDF document. Let us give some time to open this document. Yeah, so this is the document, which is 272 page long. So I don't tell you to read all the 272 pages, but you will find this document useful. So all your 4 labs this semester will be based on this Silicon Lab tool sticks, this particular model, C8051F020, and whatever you need to know about this particular hardware, you can get all the information from this description PDF. Okay, so whichever part you need, you can just directly go to that particular part. So for example, let's say you want to know about the timers, so you can click here and you will be directly redirected to the timers chapter, and then you can get all the information related to the timers. So this is the entire booklet that you have for this particular tool stick. So whenever you need it, or if you need it, you can refer to it. And then if you go back, so you will also see there is a short file, a short PDF, which is this one, which is about 2 page. So this gives you an overview of the C8051F020 chip. So what are the clock rates, what are the voltages, and what else. So mind you, this is a very advanced chip that you will be using. So in the lecture, in the first lecture or the second lecture, I told you, if you recall, that there are a lot of different versions of the 8051 chip that are manufactured by different vendors. So this is one of the versions. So this is a quite advanced version, but it is code compatible with the 8051 family. So that's why you will be writing assembly language codes, and then you will be running this chip, and still it would be all right. It will be compatible. Okay, so in your labs throughout this semester, you will be using this chip and you will be running assembly language codes that you are learning in the actual theoretical lectures. and still it would be compatible. But this particular chip has a lot of advanced features, so I will come to those when we will do the next labs. I will tell you exactly what are the differences that you need to know about this chip, okay, which are not part of your theoretical lecture. So this is the short file, and then if you again go back to this toolstick folder, you will see there is this file which actually gives you the handling recommendations. So this is also important. You should be very careful in handling this chip because this is a very expensive chip, and you don't want to damage it, right? You basically don't touch the chip directly like this. This is the improper method of holding the tool sticks. Always hold as shown in figure 1. Okay, so that is important. So, and then this is the actual chip that you have, and these are the different parts. You have switches, LEDs, reset switch, the actual microcontroller chip here, and then you can see there are different parts, so we will be using them along the course of this semester. So you will know them when you are actually using them in your labs. Okay, so that is more or less about the hardware here. And then if you go back to the labs folder, then so that was the tool stick part here. I recommend you to go through these 3 PDF files. And then you have this section which is the software download section. So if you click this page, you will see that there is a zip file. So you have to download this zip file and then extract this, and you will find 2 exe files. So you should download all these exe files and then run them and install the software. So one exe file is for the actual software, which is called Kyle Microvision 5. That is the environment, that is the software environment on which you will be writing your codes and then compiling them, and then those will be executed on the hardware. And then there is another driver file, so you should download that and install that as well. And you have to use a Windows operating system for both of these software to run. So if you are using a MacBook, I strongly recommend all of you who are using MacBook to install Windows on your machine, or use the Windows Parallels software, which can run both Windows and Mac OS parallelly on a MacBook. So anyway, you have to make this arrangement. So you have to have a Windows operating system to run these 2 softwares, and you install that on a Windows machine, and make sure that you install both the software in the same folder. Okay, otherwise there will be some errors in running the codes. So I repeat, this is very important. Create a folder and give a name to it, whatever you want, but install both the softwares in the same folder. Okay, one is the Kyle Microvision software, and the other one is the Windows driver software for Kyle Microvision. Okay, so install them in the same folder. So this is the software download part. Next, if you go back again to the labs file, then you will see here of part called lab1. Okay, so inside the lab1 unit, I have put up this Word file. So download this and have a look. This is the Word file for the instructions. Okay, so these are the instructions that you actually have to follow for the lab1. Okay, so this is like um, you first set up and then you do the assembly and then how to report. Okay, so download this. I again I tell you, you should download this in your PC and then open it, because from here everything is not visible. You see, here is a diagram which is not visible here. So let me download this and show you what exactly it looks like. Okay, so so yeah, so you see, here are some snapshot of the actual Kyle microvision environment. Okay, if you install that software, Kyle microvision 5, this software Kyle microvision 5, sorry, this one, and then if you open that environment, it looks like this. So you write your code here like this. So this is the file which tells you what exactly you have to do for the lab. Okay, and here is the way how to report it. Okay, here is a mistake. Okay, I have to remove blackboard and write bright space here, because this year we are using bright space, we are not using blackboard anymore. Okay, so this is the instruction file for you, so read it carefully to find out what you have to do. And then if you again go back to the lab1 folder, you will see here is a compressed file called 01 underscore lab1. So basically this is a blank template. Okay, this is a blank Kyle microvision template. So I have uploaded it for your convenience, so you can directly download this and then extract the components under this or uncompress this file, and then you can click the Kyle microvision file directly, and that will land you up directly to your lab1 task. Okay, and if you open this, you will see that some parts of the code are already written for you. Okay, so since this is lab1 and this is the beginning, I have made things a little easier for you. Some parts of the code are already written for you. You have to just fill up a certain portion of the code which is left blank. If you open this, you will see what's actually I mean. Okay, so this is the instruction and the template here, and then if you again go back, you will see that here I have the lab report template. Okay, so after you finish your lab successfully and complete everything, this is the Word document that you should download, and this should be the template of your report. So after every lab you have to write a report to reflect everything that you did in the lab. So write every process that you followed for the lab, and then if there are any observations, write them down, and then if you have any conclusions, write them down. So this is the template for the lab report. Okay, so you give the date here, you write the lab number, so lab 1 or lab 2 or lab 3. You can create group of 2 students among yourselves. So this will be the group, and then you write clearly the name of the group members and their UCD student numbers, and then here it's mostly blank, so you fill it up according to your own way, but make sure you mention every step that you went through in the lab, all the details, processes, and also if you think that you can take some pictures of your outputs, feel free to do that and paste it in this report. And of course you have to copy and paste your code, either copy or paste your code or take a picture of your code directly from the computer screen, or take a screenshot and then paste it on your report. Okay, and then you will submit the report on Brightspace. Okay, so that is the report for you. And yeah, so that is everything for lab 1 for you. And then I will show now how to actually run the Kyle microvision software, and how to set it up for your lab. So how to make it work. Actually there are a lot of settings which needs to be done, so I will show it now. You will see that there is a desktop icon created here for Kyle Microvision 5. So now I double click on this, and then your development environment will be open. So this is your workspace, and the first thing you should do is to open a new project. So if you go to the project here, and if you say new microvision project, and you name your project, so let's say I name it as lab 1 and save. Immediately after this step you will see a prompt like this, where you have to click for the actual hardware module that you are using from this list. So I click here and I click on Silicon Labs custom database, because you are using the Silicon Labs hardware. And then if I click here, you will see the list of all of the hardware that's available from Silicon Lab. I go down, and in your case, or in our case, the hardware is C8051F020. So I click here and I click OK, and you press no here for this particular part. So now we have the project added, and we have a target, we have a source group. Now we do a new file, and a new text file will be created, and all you have to do is to write your code here, and then you have to run it. So for running a code, I will show you an existing file and show you how to run it. Okay, now let me show you how to open a project. So I showed you how to open a new project and then choose a device, but here I will open an existing project and show you how to run it. So if I go to project here and I click open project, then I'll be going to this particular directory in my laptop. So it all depends on where you have saved your projects. So in my case, my projects are saved in desktop, and then a folder called ASM, and then this is the name of my project. So inside that folder I have all these files, so I will just choose this one, which is a microvision project, and I will click open, and I will see that I have all these assembly language codes that is written here. So I'm going to run this code on the piece of hardware that I have, which is the Silicon Labs hardware. So the first thing I have to do is to go here. So this is called options for target. So on your top panel here, just after the target part, you have a small button like this, which is called options for target. If you click this, then you land up with some dialog boxes. So here I will show you that in the device part you have already selected the device. So this you did when you were trying to open a new project. So this part is done, and then if I go to the target, you make sure that this box which says use on-chip XRAM is ticked and not this one. And then I go to the debug part, and here you see that use Silicon Labs C8051F XXX driver is already selected. If it is not selected, then make sure you tick this circle here, and from the drop down menu select the Silicon Labs C8051 drivers, and then you go to the settings of this and make sure that the serial adapter is USB debug adapter. So you have to tick this circle here if it is not ticked. Sometimes this RS232 serial adapter will be ticked, so you have to make sure that you are ticking the USB debug adapter, and then you click OK. And then you go to the utilities part, and in the utilities part make sure that you tick this part, use target driver for flash programming, and you select Silicon Labs from the drop down menu here, and then click on the settings and make sure all these boxes are ticked, and then you click OK, and then you are done. So you click OK. So the main thing here is that you make sure your device is right, your target has the XRAM on chip. In your debug section you have these Silicon Labs driver selected, and in your settings you have this USB debug adapter serial adapter part selected, and in your utilities you have this use target driver for flash programming part selected, and the Silicon Labs driver is selected, and all these boxes are selected in the settings part. So now you click OK, and then you have to click this box which says build. So this is with one arrow compared to the double arrows here which is rebuild. So you have to click this box build, and you see there are no errors and warnings in your code. So this is built, and then you have to click the load part, which will download this code onto your target hardware. So if you click load and you click yes, and then you click OK, so your load part is done, and then you click here which is start/stop debug session. So you click this part and click OK here, and then you land up with this windows. And here if you click run, then your code will be running, and your USB device will be reacting according to the code, and I will show you how this is running. So here your code is running, and here you have the software that is running, and your hardware is running.